All right, so I think we're done with the quiz. Just random stuff you can put underneath the desk for some reason. I don't know why there's a helmet or metal, but that's all. But there's all sorts of stuff down here. It's very fascinating stuff you find when you decide to look. Okay, so so right now I think what we're going to do is that we're going to put a hold on where we are for right now and just kind of give you an idea of where we're going, which is something that I feel is kind of just something that you might appreciate. So one thing to know about this is that basically programming languages are fairly straightforward. They only are made up of like 3 different types of statements. 3 different types of statements, right? And we've already learned one kind of statement, which is the imperative statement, which simply says, do this thing. So over here, like print hello, that is an imperative statement because it's a command. And I'm just simply saying, do that command, and it gets done, right? Print hello. X is equal to 5,000. Print 5,000 squared, whatever that number is, right? Those are 2 imperative statements back to back, right? And it prints out that number, right? So this is the script, and then Python goes and follows that script as well. There's also there's different types of statements we can do as well. There are 2 more types: selection statements and iterative statements. So selection statements basically are what we'll see with the if-else statements. We'll see those with basically with if-else statements, and then for loops, which are basically our iterative statements, repetition. So basically being able to make choices and being able to repeat stuff. Basically, those are the key components to writing any kind of programming, any kind of program. So over here, let's just go ahead and do some basic input-output, right? And what we're going to do over here, and we're going to do something fairly straightforward over here. Let's say, so, yeah, that makes sense. So let's go ahead and do this. Grade is equal to input. What grade did you get? And that will be a question mark. And then print, you entered. There's going to be a lot of going back and forth with this one. You entered grade. And what we want to actually is the quotation mark over here and then do a plus over here. You entered grade. So here with input, the way this works is that whatever we put in the parentheses of input acts as the prompt for our input. So here, if I do what grade did you get, space, run it, it'll print out what grade did you get, and then it will leave, and then it'll do space, right? Because I asked it to do a space, and then it just simply set, and then it just simply is waiting for me to put in what I said. So I'll put in 100. You entered 100. Great. Okay. Another way we can do print statements, by the way, is with commas. We can separate it by commas. So I can do you entered, comma, grade, and it will print those things separately. What grade did you get? 100. You entered, and then it'll just separate whatever I put in there, whatever I want to put in there by a space. That's another way to do it. And you can do as many of those as you want. So that'll be useful. But for right now, I'm going to go ahead and keep it with concatenation. Okay. Now, here's the question. Is that a passing grade or a failing grade, right? So we want to print out something different if it's basically a passing grade and if it's a failing grade. Before we can do that, we need to turn grade into a number. Right now, it's what? What is grade right now? What's its type? I heard it, string. So grade is right now a string. So if I try to do greater than or less than on it, it's not really going to work, right? If I try it, right? So if I try it over here and do, like, if I tried to compare 100, oops, it's a bit hard to see over there. Show. Box. Okay, give me a second. I want to make sure that it doesn't get cut off on the bottom. Because otherwise it's a bit difficult for you guys to see. All right, so there we go. So if I try to do 200, if I try to ask if is 60, is the string 60 less than the number 70? That's going to give me an error. Wait a second. I can use less than, greater than, plus, and those kind of operators? And the answer is yes, you can in Python. So this gets us into a new type of statement called the Boolean statement, or the Boolean expression. So, Booleans are a very interesting type. They are named after a British dude who did a lot of research onto logic, George Boole, with an E on the end. And because he, and so, yeah, that looks Victorian. So anyway, he did a lot of stuff on laws of thought and Boolean algebra, basically dealing with stuff on truth-false values. And so he was a professor and he did a whole lot of math stuff. But what we care about is true-false statements, which are, so things in Python have a truthiness value and a falsiness value, or true and false. So the two Boolean types are true with a capital T and false with a capital F. Okay? And Boolean statements or Boolean expressions are expressions that don't resolve into a number, but rather resolve into a Boolean. So for instance, 5 is less than 7. Is that true or false? It's true. 5 is less than 7. So that resolves to true. What about x? What about, let's say, x is equal to, let's go ahead and say x is equal to 5, which means that 5, we store the value of 5 inside of x. X is less than 7 again. Here's the same answer, true. X is greater than 7, so is 5 greater than 7? Right? X is 5 here, 5 greater than 7. That is false, right? It's always going to resolve to true or false. There's not going to be an indeterminate answer here. Right? What we can also do is we can do something. So let's go ahead and just talk about what kind of what type of things we can compare. We have our logic. So these are. So here we have our. We've had our basically our binary operators, right? 1 and 1 plus 1. Whoops, 1 plus 1 gives us 2. Right here, though, we're looking at logical operators, essentially things that were Boolean operators, things that resolve into true or false. So here, 3 less than, so is 3 less than 3? False. 3 is not less than 3. It's the same as 3, right? 3 less than or equal to 3? True. That's true, right? So because there is no less than or equal key, right, on your keyboard, we have to make do. And so we do basically that annoying thing that you often see, less than or equal to. Once I move on to, I'm actually going to just check something right now. Configure idle. Am I using Fiora code? Yes, I am. So what you'll see is that when I eventually move on to Geany, or using a different editor, you'll see actually that my font will render less than or equal to as one symbol, which will be very useful. But for right now, to avoid confusion, it's not going to do that. Less than or equal to, so less than or equal to, so we have less than or equal to, we have greater than, and greater than or equal to, right? Which checks if two things are are basically greater than or equal to. So how do you do equal to? Right? Your first thought might be the equal sign, but it says you can't assign to a literal. So remember what I said last lecture. This is not equal sign. This is assignment. This is not asking if two things are equal or creating a permanent binding between things. This says take the value on the right and store it on the variable on the left. Now the reason we have this equal sign is because I think it has to do with laziness, to be honest. A lot of programmers are pretty lazy, and we don't like to hit a lot of buttons. But let's just think about this for a second. Really, a lot of times in pseudocode, what you'll see what you're going to see for this is a left arrow in pseudocode. In other words, code that people write that's not for any specific language. So you'll see sometimes it look like this arrow, right? You'll often see that for an assignment statement. So x is equal to 5, right? This assigns the value of 5 to x. Okay, now let's try and make a assignment statement like that in Python. X gets the value 5, right? Except that gives me false. Why? Because we're saying x is less than -5, right? So arrows won't work because drawing an arrow like this won't really work, right, in any programming language. Would have been convenient, but the computer would get confused whether or not we meant less than negative or, you know, an assignment statement. And we kind of want that less than negative. All right, so eventually what was decided on in some programming languages was to do something that looked like this, which if you squint real hard looks kind of like an arrow. Colon equals, which if you squint really hard, I guess, it looks like an arrow. And eventually that just got shortened into that. So there's your history of the assignment statement that I've been able to piece together. So assignment statement is like that. So how do we compare and check if two things are equal? Well, we use double equal to do that. 3 double equals 3 means that we want to literally check if those two things are equal. True is true. By the way, we can do true and false values on things that are not in fact, in numbers. So for instance, is hello the same as, so basically if I say, hey, s is equal to, or let's go ahead and be better with the variables. Word is equal to hello. And then let's do some more stuff, like pretend that we go further down, and then we ask, is hello, so is word equal to hello? And it'll say true, right? It says that word has hello in it, and does it have world? False. That's cool. So you can do that kind of comparison as well. One thing that basically we can do is that we can see this. Let's learn another function. Len of word equal 5. So what is len of word? Any guesses? Length. In other words, how big of a string it is. So if the length of word is equal to 5, true. Len of word less than 5, false. Hello is 5 letters long, so it's not less than 5. So that's why we'd get a false there, right? So the primary operators we have are less than, greater than, less than or equal to, greater than or equal to, and double equals to check if two things are equal to. We'll eventually learn about a couple others, like in. The other thing to learn is that, and we'll get into these in more detail later, is that we can make these Boolean statements more complex. We can say if. So, or rather, we can do basically if x is greater than 3 and x is less than 10. That's true, right? X here is 5, so x is greater than 3. That is true. and x is less than 10. So an and statement, so basically you have two operators here. And, which says that both sides of the and are Boolean expressions, and they both have to be true for the entire thing to be true. And or, which says that only one side has to be true. So if x is greater than, so let's go ahead and say, I'm trying to and actually I'll get into that more later, because really I'm not meaning to show you, I'm only trying to show you enough of what you need to know for your assignment before we go in more depth on it later, okay? So one thing that may help you on your assignment, and one thing that is kind of unique to Python, is the ability to do, is that, you know, x is greater than 3 and x is less than 10. You wouldn't write it like that if you were trying to do equality in a math class, right? You'd write the expression something like this and reorder it. 3 is less than x, which is less than 10, right? Everybody seen something like that, right? Now, in other programming languages, this is a no-go. No, no, no. You cannot do this in other programming languages. Python goes, yeah, whatever, sure. So you can totally do it like that in Python. So how does this play into what we call if statements? So let's go ahead and take a look at that. So let's go ahead and try changing this a bit differently. Let's go with input, enter a word. And what we're going to do is, so we don't really have to change things, I'm just going to simply, this is a much better way to do this and introduce the if statement. Word is equal to, so we're going to enter that word, we're going to ask the user for a word, we're going to enter the word, and then we're going to basically tell them whether it's a big word or not. So a very simple example to show an if statement, an if-else statement. So the way we use Boolean statements is that we use them as part of if-else statements, and it looks like this. If, and then I'm going to replace the expression, so don't type down the whole thing, right? Don't type down this, what I'm doing here. Right, so this is an if-else statement. Basically, it says if this Boolean expression is true, I want to do something. Otherwise, if it evaluates to false, I'm going to do the other thing. Okay? So in this case, what I'm going to do is I'm going to set up a very simple expression, which is if the length of the word that the user enters is greater than 10 letters long, I'm just simply going to print out wow, that word is big. I know, very boring, but it gets the point across. Print. Entered. Let's go ahead and make this a bit easier. Wow. Semicolon, space, plus, word, plus, is a big word. Just like that. There we go. So now we run it. And what we see here is we see input, enter a word. So I'm going to enter Excel's, how do you spell it? Excelsior? I don't know. It's a good word that's more than 10 letters long. Aristocratic. There we go. That's surprisingly more than 10 letters. Wow, aristocratic is a big word. Okay, and then it just hangs up there, right? We run it again, and it goes, and we can go enter a word. let's go ahead and do word. Okay, you entered word. So this is the way the if statement works. If the Boolean statement is true, we do the indented condition. Otherwise, we do this indented condition. Print program is done. So let's go ahead and run that again just to get that across. So if aristocratic. Wow, aristocratic is a big word. Program is done. So in Python, what makes it very unique and what made it what was very unusual to me was that white space matters in Python. And by white space, I mean this space over here, the space that you can't see. Here I hit tab and it automatically converted it into 4 spaces. Python, the way Python knows what is part of one statement and one part of one block of code and another is the indentation. Like, so to give an example, give another example, you entered word. That was pretty boring. Print. Try something else. Okay? So now I'm going to run this again. Run module. Enter a word. I'm going to enter aristocratic again. And says, wow, aristocratic is a big word. Notice that it didn't run anything else under the else condition. It all it did was run, wow, aristocratic is a big word, and then program is done. However, if I instead run this again, and I enter small, you entered small. That was pretty boring. Try something else. Program is done. It executed these 3 lines of code that were under the else block. How does it know what's within the else block and what's within the if block? Right? How does it know what's part of it? It uses this indentation, right? Python just will know what is part of the if block and what's part of the else and what's outside of the entire thing based on the indentation. Does that make sense? Any questions? Right? So once we're outside, so these intents, they're useful tools for us to that basically let us simply, know what is part of what block. And we'll see this as well with the repetition statement. I swear I'm going to somewhere coherent with this, so I'm just trying to build up to something pretty fun. So all you really need to, you can, by the way, chain these guys together. So for instance, if I do if len, so first off, I'm going to go ahead and comment this out just to simply show you a couple things. Remember, so this is a useful thing, commenting out something. Remember, a comment is this hash mark, and if you put a comment in front, it's just not going to execute this code, right? It's not going to see it. It's invisible to the computer. Okay? So if I go ahead and run it, enter a word, it's just not going to run something unless it's big, right? So you can have an if statement without an else, and that's just simply saying else do nothing, right? Right, this kind of acts like as a detour for the program, right? Whereas if you have an if-else, you've got to go down one of the 2 paths, right? So you can have a bunch of detours chained together. If len, so here I'm going to copy, paste. If the length of the word is greater than 12, is a really big word, okay? So now we do, so now if we run this, we have 2 independent if statements, right? If the length of the word is greater than 10, if the length of the word is greater than 12. And what I mean by independent, they don't keep track of one another, right? These are completely independent of each other. Remember, computer is not an almighty deity. It is an evil genie. It is going to do exactly what you say, and it doesn't matter what you mean. So here, if I enter aristocratic again, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Aristocratically? Sure. It'll go, wow, aristocratically is a big word. Aristocratically is a really big word. Program is done. So, right? Now, why did it do that? It said, I executed enter a word, stored word. If length of the word is greater than 10, execute the indented block. Wow, it's a really big word. Then go on to the next line, because we're done with the if block. If the length of the word is greater than 12, execute, wow, it's a really big word. So, one way to get around this, and you'll find this out with the if statements, is to, if you don't want both things to execute, sometimes you do want both things to execute, is to chain them together, or is to make them else if statements, right? So one thing we could do is that we can make these like this. Don't write this down, by the way. I'm going to replace it because it's ugly and undeserving of being, it's just wrong. It just doesn't look good, okay? Notice that this starts to get looking complicated, right? How do you know which part is part of which if statement? Based on the indentation, right? So you can nest these suckers. You won't need to for our first program, so don't freak out about it. Right? For this program, we're going to just deal with stuff that's on the single, that's only has a single level of indentation for right now. We don't want to get too deep in having to read this. So, but let's go ahead and read the way this works. If the length of the word is bigger than 12, I'm going to say, wow, word is really big. Also, note that that basically for every if statement, we have a colon. This lets Python know that we've got an incoming indentation. Okay? This lets it know that we've got a indentation coming. Wow, it's a really big word. Else, if it wasn't a really big word, we're going to check if it was just a regular big word. And if it wasn't that, we're just going to print out, you know, that part. So, and let's just go ahead and run it and prove that it works. Enter a word. And I'm just going to pound on the keyboard. Right, really big word. A. That was you entered A. That was pretty boring. Try something else. Okay. So this is ugly. It's an abomination unto whatever god you worship. But what these are is that these are interdependent if statements or dependent if statements. They're if statements. This if statement, this else if, these only execute based on. These only executes based on whatever you've got they execute only based if the other ones don't execute. Only one of these is going to execute. So for instance, if I enter, again, aristocratic, not aristocratically, just aristocratic, it's just going to say it's a big word. Right? So this one didn't execute, but this one did. So it didn't execute the other one. But this is a bit complicated to look at. Everybody agree that it's kind of, even though it's not that many lines, it's a bit complicated. So there's an easier way to write this. And that's to use something called elif. Oh, look, that cleaned up pretty nicely. Oh, that looks a lot nicer. So elif is short for else if, but that's the way you do a else if in Python, which is that if it's greater than 10, it's greater than 12, do this. Otherwise, if it's greater than 10, do this. Else, do this. And this just simply lets everything be interdependent on each other. Right, only one of those will execute. Now, for your homework, you have two options. You can nest your if statements. Basically, for the 3 small programs problem, you can nest your if statements. And you can basically go, oh, if this number is bigger than this number, smaller than this number, right? Or you can use basically this tool over here, right? Which is that you can say, hey, if 1 is less than 2, 1 less than 3, right? You can use that, a unique feature of Python, which is pretty nice. Whichever way works for you. So that's the if statement. The other thing, though, is, so I'm going to skip gears again, and again, I want to kind of just show you where we're leading up to over the next couple of weeks. One of the things we're going to be working with in the book is something called turtle graphics, which is pretty cool. You can go and open up the web page for our Runestone Academy and click on this link. It's pretty cool. So turtle graphics were designed in the the 60s. It's a really easy way to do graphics. You don't have to know. We're going to go into more detail about this stuff, but really what we're doing is we're getting a little turtle. It's this arrow here, and he just simply follows the directions you give him. Actually, let me go ahead and give him a shape. Let's see if that does this. My underscore turtle is equal to, my underscore turtle dot shape is equal to turtle. Will this work? The nice thing about this is that you can execute these and run them. Yeah, turned him into a turtle. Fantastic. Great. So, right, that's going to be hard for people to see in the back. But anyway, so a couple things going on here, but this is where we're going with these, okay? Which is that we can, oh, cool. Keeps my changes. So, what is a turtle? So, we've been learning a lot about different types of things. We've been learning about integers, floats, strings as for terms of types. Most types fall under the category of object. You can think of objects as the nouns of the programming language. They're things that can perform actions. So here is a turtle. To use turtle, we have to do something called an import statement. And by the way, I can totally just copy this out into my into here. Turtle demo. It is of the utmost importance, by the way, that you don't call a program turtle.py, because then Python might think when you're trying to import turtle that you're trying to import from yourself, and that's going to be a bit of a mess. But you can see that I can run it over here, not just in the browser, right? And what this import statement says is that you're telling Python, load up the turtle module, please. We're going to use turtles. And then the code over here is pretty is explained on the side. My turtle is equal to a turtle.turtle. And what this does is that's just a weird way, but it creates the turtle for us. This code over here changed the shape of the turtle to look like an actual turtle. And then I changed the color of the turtle to green. Now, the way turtles work are fairly straightforward in terms of graphics. Imagine that you're looking top down on this little bugger over here, okay? And what you're doing with turtle graphics is that you are telling him to do certain actions. Essentially, imagine this: you're looking top down on this turtle. And it looks a bit bigger over here when I run it. Oh yeah, because I'm zoomed in. And what we're doing over here is that imagine the little turtle's carrying like a marker or a pen or something in his mouth or on his tail as he moves. And what he's doing is that as he moves, he's dragging it and he is marking that space with the pen as he moves. So here, what we did is that we told him to go forward 50 steps. Okay, step is pretty arbitrary, probably pixels or something like that. Okay. And then we had the command called up, which tells him, hey, lift up your tail so that we're no longer dragging that, so you're no longer dragging the pen behind you. And then we told him to move forward another 50. So we moved forward 50 steps. Then we told him to lift his tail, which lifted the pen, and told him to move forward another 50. Now, how do we get the guy to turn? Well, it's fairly simple. We tell him to turn left or right. Okay? And if we tell him to turn right, what we put in here is 90. We can put in right or left. Right? My turtle.right, that tells him to go left or right. And then down allows him to draw again. And then backward, that moves him backwards. So he moved this way, turned 90 degrees in this direction, and then moved backwards. So let's go over here and see, again, over here, what we're doing. And there's a reason I'm doing this. This will get into repetition. So I'm going to create my own turtle. I'm going to call that turtle Bob. Turtle.turtle to create the turtle. Okay. Again, we're going to work with turtles more in the future later. This is just to show you where I'm trying to get us to go. Because topically, we're going to be eventually writing a hurricane tracker with turtle. So interestingly enough. I know, how topical. That'll be somewhere around the mid-semester. So that should give you an idea that turtle graphics are actually fairly strong. So here I'm creating a turtle. If I run this, right, not really anything happens. Let's see. Did I miss anything? Do I have to actually tell it to move? I'm going to just go ahead and say, hey, Bob.shape. I want to change Bob's shape to be an actual turtle. And then we're going to tell Bob to move forward 50 steps as well, so that we can see him in action. So here, told him to move 50 steps forward, just like that. Okay. And now if we do Bob dot right again, here I'm going to move him forward 50, and then I'm going to have him turn to the right. See? Turns right 50 degrees, though. If I want him to turn 90, boom, there we go. All right. So, and then if I copy and paste this a lot, right, I can actually do something a bit fun, right? Go forward 50, then turn right 90 degrees, then go forward 50 and turn right 90 degrees. 1, 2, 3, 4. Boom, did the square. How awesome am I? Not that awesome. This is pretty lame, to be honest. I know. Okay, but first off, doing the whole Control-V, Control-C thing was a bit tedious. Okay? Like, if I want to change this to make it a bigger circle, I have to go change one of them to 100 and then copy-paste the rest. Now, if there's one thing that programmers hate, it's doing a lot of work over and over again to basically barely change anything. So what we can do is a special type of loop called the for loop, or a special type of statement called a for loop. And this is our last type of statement, the iterative statement. And I'm just going to teach you again the basic shape of it, which looks like this. And it's fairly straightforward to look at, but right now we're just going to look at it in the most basic form we have. This is what I might call a kata, like in martial arts, like a form where you just kind of put in the muscle memory. So for blank in, a lot of gibberish right now, range 4. But what this simply says is the following code that's indented, I want you to do it 4 times. Whatever's been indented, please do it 4 times. Boom, boom. Typically, you're going to see it something like this. For variable, so for x in range 4, boom, 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 right? And now we did it 4 times. This can be whatever number we want it to be. So here, although for the turtle, it's not really going to change the drawing too much, right? 1, 2, 3, 4, and now he's just simply going over his space again and again and again and again and again and again and again. But what's interesting, though, is the way this for loop works. Now, right now we're just simply using it to repeat things again and again, but this entire idea of having an x here in this range here is that this goes through certain numbers. It goes from 0 to 99. It goes up to, but not from 0 up to, but not including this number over here. So error, program exceeded time runtime limit. So that's an interesting error that you're not going to get that in Python. You're just going to get it in the browser where it doesn't like things to run forever. Okay. But what I can do, and this is just simply show, and this is again going to just show you what we can do later on. X plus 1 times. I'm not going to explain this yet. Don't worry about it. Don't worry if you don't understand that. This is, this has all been showing you what we're leading up to. And I can make a spiral by just simply modifying that code just a little bit. And what I did is that this number goes up. This number goes up every time we go through the loop. It starts at 0, then it goes to 1, then it goes to 2. So I started at 100, and then I said add x plus 1, so add whatever value x is at, right? X is going to go up to 100, 1 by 1, and multiply it by 5. And so the first time, I'm just going to move forward 105 steps. Next time, I'm going to move forward 110, then 115, 120, and so on and so forth. So what we can do, and this gets more obvious if I start off over here, like on 5. And now we've got a much tighter spiral going on here. So, and you can see basically that what's nice about these things is that you can kind of, if you're having to review geometry, this is a great way to do it. There's all sorts of interesting things you can do with turtles. But for the most part, this is where we'll lead up to with turtles, and with our if statements. And notice over here we got ourselves a time limit error, right? There's various different types of errors you can make in Python, and this is the last topic I think for the day. So there's a lot of different errors you can make in Python. So one of them is basically, let's see. You know, I've spent my entire life avoiding the errors, so coming up with them on the spot is a bit difficult. One basic one is syntax errors, right? Basically where the grammar of the syntax, the grammar of the sentence you're writing is wrong, right? Like, let's see. Let's see. So, like, for instance, consider the sentence, we eats apples. Okay? We eats apples. Here's, that is, eats is wrong. Eats is wrong in the sentence. It should be, we eat apples, right? But I still get the meaning across, and it's not like I immediately keel over and die just for having, you know, the wrong, you know, syntactical error, right? My syntax is wrong, my grammar is wrong, but it's not really got any consequences other than looking a little silly. Here, though, if the grammar is wrong in Python, then it just won't help. The program won't even run. There's various types of syntax that are wrong. For instance, having an indent start where you don't want one. Here, syntax error, unexpected indent. Trying to use a variable before it's created. So here, x is not defined. Name error. Right? There's all sorts of errors that can happen. All those errors can be found in the 3rd chapter, which is not really something we're going to go over too much. But that chapter is on debugging. Let's take a look at it anyway, since we've got 15 minutes left. Let's see. Yeah, so we'll see over here. So, function calls. So there is something to do still. Function calls. Let's see, do we introduce this to write functions? Right. that's something I don't want to skip. That seems important, more important than that. So I've talked about turtles for a second, and turtles are nouns, and I said they can perform actions, right? Turtles are objects, and the objects in the programming language are nouns. So if there are nouns, it makes sense to say that there are also verbs, which are function. Now, as we progress through this course, we're going to learn how to write our own nouns and verbs. Verbs are actually easier to define, or functions are easier to define. And they look like the mathematical types of functions. So let's take a look at this. Min 3, 1, 5, 6, 7, 2, 4. So functions, in general, they return something. In other words, they give me an answer back. So min 3, 1, 5, 7, 2, 4. The commas separate a bunch of arguments, right? Normally in mathematics, if we were to see something like this, if I were to see something like this in math, f of x, y, z, that would start freaking you out, even if you didn't see anything else, right? That indicates that something really complicated is coming up. In computer science, we deal with that stuff all the time because it's actually not that scary. So here, min gives me the smallest of the arguments, which is 1. Makes sense, right? Of those, 1 was the smallest. If there's a min, there's also a max function, right? Right? So Python has a number built in, right? Where you can figure out, given a bunch of arguments, this will give me the biggest one back. And by return, I mean that what we can do, is something like this. X is equal to minimum. So this will take the value on the right and store it on the left. Now, everything on the right is an expression, and it evaluates, right? This was this minimum function call over here, where we were using the function called min. This was something that evaluated, right? It evaluated to a value. Max evaluated to a value. And so if it evaluates to a value, that means then we can put it on the right side of an assignment statement. In other words, we can put pretty much everything onto the right side of an assignment statement. X is 1. Here, let's go ahead and do that with the max. X is equal to max. Print out X. X is 7. Okay, but why stop there? X is equal to max plus min. What's X's value? 8, right? It's equal to the biggest thing from that collection and the smallest thing from that collection. 7 plus 1, the two answers we got. So you can combine these. Pretty well. Let's see. There's a lot of mathematically defined ones like abs, which does not actually refer to any kind of muscles or anything, but instead refers to the absolute value, right? So abs of negative 7, right, gives you 7 back, right? Abs of 7 gives us 7. We also learned about the len function, which is also very useful, like the length of a word over here. 4. Okay, there's also some other cool stuff here, like CHR 97, for instance, which of course everybody knows that that's going to give us A. What? Right? What in the world is CHR? Anyone? Yes. Yep. And again, you have no idea of knowing that unless you've touched programming earlier, and it's perfectly fine if you haven't. That's the vast case of the majority for other people. But I'm just simply letting you guys know which people to bug to help you study. Oh. So character. So the way characters. Remember a while back I said that everything in programming is just a bunch of zeros and ones. All this is a rock and a bunch of electricity that we tricked into thinking for us. I mean that. So all the letters and stuff, they're encoded in numbers. So that has some interesting consequences, like CHR of 97 plus 1 gives us B, right? This comes from an old chart, by the way, called ASCII, right? Back from our ASCII art. So ASCII table, and the term ASCII is American Standard for Information Exchange, and it was used for basically a long time. Since it was American, basically it completely ignored that the fact the entire rest of the world, by the way, and the fact that, you know, not everybody uses the English alphabet. But here's the ASCII chart from 1972, right? And what it says is that basically is that here's your bit sequences, and here's the various ways that will work, right? What are your bits? That you get 7 bits to a letter. So 0 is null. Let's go ahead and find a better table for this, because honestly, this one is not that great if I want to show it off. So images, always risky to click on. Come on. Google, why did you change the way that your stuff works? Okay. Oh, this is nice. So 0 corresponds to a null character. A bunch of this has to do with like typewriter stuff. If you've ever heard an old computer beep at you, it's because it was responding to a 07 character. So you can actually type out text to make your computer go ding if it still responds to that. Backspace, an actual key thing. Carriage return, we don't see that anymore. Anyway, so a bunch of stuff. 20 is over here. 32 corresponds to the most common character in the alphabet, which is not E, but space. The most common character is space. Then exclamation part. So every single one of these characters gets an encoding. Every single one of these letters, up to 128. Because you get 7 bits, and if you work out the math, it turns out that 7 bits is 128 different combinations. Now, some of you may have noticed that there are more glyphs in the world than 128. And also there's 7 bits. Things normally come in 8 bits, so there's normally 256 characters. So it ends up being a lot of things. So this was eventually replaced by Unicode, which extends ASCII. In other words, it's backwards compatible with ASCII. Or rather, ASCII is forward compatible, I guess. So this allows us to do stuff like CHR of 1000 gives us that weird character. We can also take this character over here and ask, hey, where is that on the ASCII table? By asking ORD. And it'll say that's on 1000. And so what I can do is that I can say something like this, if you want to find out what the next character is, let's see, and this will be the last thing I torture you with. If I go over to Japanese again, input mode, hiragana. If I go and do ga, the hiragana for ga, if I do that and I ask for the ORD, I get 1, 2, 3, 6, 4, which of course is going to be super easy for me to remember. It's not, so I'm just going to copy this. So if I do this, add 1 to it, and then ask for the corresponding character, I can figure out what's next on the ASCII table, which is apparently ka. So, wait, no. Yes? No, key. Key. That's key. Not, here we go, not ka. This is ka. Okay, so, but anyway, but notice that we have a function call inside of another function. So I think that's a pretty good way to pick up on Thursday. So we'll pick up on doing more function calls on Thursday, and then we're going to go into more, and then I think on Thursday we'll have some fun in class playing with turtles. please don't bring live turtles to class. Also, I have office hours tomorrow, noon to 3, like I do every week.